All right, so I'm going to set up some ways of thinking about a data set that will help us understand summation notation when it comes to statistics. And this will set us up to understand a whole lot of things as we move ahead with our study of statistics. So I want you to start thinking about any data set of continuous data or discrete data, so some kind of quantitative number type variable. And I want you to think about a number of observations, okay? And I'm gonna write up here a way that we can think about multiple observations within a data set. And these are all gonna be values of y, okay? So y, because y is our dependent variable. And so I'm gonna write these as y sub I, okay? And I, this little I denotes which observation am I talking about. Okay, so it's helpful to be able to point to a specific observation in a data set. So for example, this could be the number of snails in a plot that you're measuring. It could be the number of plants in a plot. It could be the pH of a stream that you're measuring or multiple streams that you're measuring. And so each value then is a y value. Okay, so there's all of these y values in the data set. And each location in the data set, kind of like in a spreadsheet, is numbered. And so this would be y sub 1, y sub 2, y sub 3, looks like next, y sub 4, 5, and 6, dot, 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 all the way down to y sub n. And n is a special term. It stands for the sample size or the number of data points in your data set. So n equals the sample size. Okay, so this is the way that we can think about any data set of any size as a set of y sub i's, okay? And so for example, if we're looking at, say, the number of snails in a plot, you might go out to your plot and you might measure 4. And then your friend might go out and they might measure 7. And then another student in the class might measure 3, or 5, or 2, or 10, dot, 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 all the way down to the actual number, to the total number of plots that were measured, right? So I'll just put an n in, y sub n, all the way down. Just know that this data set can continue down for as large as your data set is. And some data sets in environmental science and ecology, now that we have the ability to collect data from space, are huge, with thousands and thousands and thousands of data points, right? So, so it's important to be able to manage data as a scientist and to be able to understand how it's set up. Now, if I wanted to take the mean of, let's just say that our data set stops here, okay, so we're not going to think about that anymore. If I wanted to take the mean or the average, I would add up all of these data, right, these values, and I would divide by 1, 2, 3, 4, 5, 6, right? I would divide by the number 6. And that would give me the mean value. And you've probably been familiar with the average, the concept of an average or a mean for a while. But what I want to do is I want to write out how we would write that statistically using this notation so that we can build on it, okay? So the mean, using this notation, okay, we also call that y bar, right? So y bar is equal to the sum, using this sigma for sum, of every value of y sub I. Okay, so what this means is find all the values y sub I and add them all up. Now, it's kind of confusing because there's no plus signs here, right? You're not adding this value to some other value. You're adding up every value of y sub I. Now, it needs some bounds to that. It's like, well, where do I start and where do I end? So it's every value of y sub I, the sum from I equals 1 to n, okay? So this means I go and I find I, and I find I equals 1, and I go all the way down to I equals n, and I add up all of those values. That's what this argument means, okay? Then once I've done that, I've added them all up, I divide by n, which is the sample size. So I'm hoping that this helps you understand how the summation notation is related to a generalized data set that can be written in terms of the variable y. Okay. Now, sometimes there might be another variable, x or z, okay, that goes into the calculation, and that will make things a little bit more complicated. But I'm here to set this solid foundation